before I get to talking to you about Nix, though, why DevOps? Who cares about DevOps? So I'd argue that the people who care about DevOps are the kind of people who say things like this. This works on my machine. I think this is kind of useless, right? Who cares if it works on your machine? It's really important that it works on the machine that delivers value to your users. So as developers, we're used to like writing the last line of code, and something happens, some magic happens, and then eventually, great, the code is in the hands of your users. But like that whole magic is quite complicated. It can be very complicated, and hope to make it simpler. So here are the things that I want from a DevOps toolchain or a pipeline. And for context, so in a past life, a few years ago, I was a web dev at a small web dev shop in Australia, and this is the way that we did development, right? We had development servers that I would SSH into and do development. And then when the time came to deploy these changes to production, I would sit down, make a meticulous series of notes, and then we'd schedule a time. And when the time came, I would SSH into the production server, do a git pull, and very slowly try to do the database migrations or any other changes that I need to fix up. And this was less than ideal, right? And even at the time, I knew it was less than ideal. But it took me a while to figure out why it was less than ideal. So here are the things that I want now, and I'll contrast them to the things that I had then. So I want my deployment process to be automatic, right? And this was not automatic. This is very much manual, me typing shit in. And anyway, I would want one command that I run that does a deployment for me. Nothing else will do. I want it to be repeatable. So if you're at a small web dev shop, then you only have to worry about one server. But otherwise, a lot of the time now, you have to worry about more than one server. You have to worry about multiple servers. So I want my one deploy process to be just as effective when I'm running it on 5 servers, or 10 servers, or 100 servers, or 1,000 servers. It's important that it's repeatable. I want it to be idempotent. And this isn't strictly necessary, but I think it is very useful, because it's really frustrating when you're doing a deploy to have a 40-minute process that ends with, oh, I didn't need to change anything after all. No good. I want it to be fast enough that it notices that nothing has changed and goes, OK, nothing to do here. I want it to be reversible. Now, this is great, because even if I get everything else that I want, I'm still going to make mistakes, right? And when I've noticed that I made a mistake, I really want to be able to roll back and go, OK, it's all right. We roll back. We can try this again later when I've fixed whatever mistake that I made. And I want it to be atomic. And I want it to be atomic because I don't want my users to see things that are broken. I want them to see one working site, and I want them to see a slightly different working site or service. And this is not something that I got, especially because, as I learned, if you do a git pull, it'll change the files in place, and it's very possible to have users be like, oh, what's happening? I was reading about this specifically a little bit later, and I found out that apparently the best practice with even with Git-based deployment is to have some other site that you do a another folder that you do a Git pull to, and then a symlink that actually points at where you care about, and you swap the symlink over, because a symlink is one of the few operations in Unix that is guaranteed to be atomic. So I'll come back to that a little bit later, which is why I mentioned it now. But OK, so let's start with a tiny web service. And I really like Haskell, so I'm going to write this tiny web service in Haskell. This example is taken straight from the Scotty documentation. There it is. Scotty is a Haskell library very much like Flask for Python. It's very easy to make a small web service. And this service takes one parameter here, and it inserts it between the words Scotty and meup. And I call it blank meup because I'm great at naming things. These are just details for packaging the app. So these two files that I have. And now we can get started with the Nix stuff. So what I'm going to do is I'm going to run this command called cabal to Nix. Cabal is a Haskell package manager. So what this does is that it takes the call description that I showed you briefly above and turns it into a Nix expression. Oh, no. Right, my bad. OK, it's done. It's not really important what the code looks like. If you're interested, I can show it to you later. I'm sure we'll have time for questions. So I can run one command called nix build, which should package build and package the app. Great. What happens if I want to run it again? It's already built. It knows that it's already built, and it'll just give me what it built last time. And it doesn't actually put anything in your working directory except for this one file called result. And the result file is a symlink to where the package actually lives in the Nix store. So it's like a directory that only Nix can control, that stores the contents of everything that I built. And the only way that it interacts with your actual working directory is through these symlinks. So what happens if I make a mistake in my app? What happens if I go and then I try to build it again? Oops. But interestingly, the result symlink is still there. So what Nix does is it'll do the whole build, and only right at the end will actually swap over the symlink. So if something was working before, it's not going to suddenly break because you made a mistake with your code. So I'm going to fix that and continue. Oh, also, you can run the thing that we just built. So OK, now that I did that again, this shouldn't have to build again. Oh, weird. OK, I think my vim config puts files that, yeah, it's really frustrating. Put files in places that make it look to Nix as if things have changed when nothing's really changed. So maybe let's. Yeah, see that junk over there? Not good. But anyway, Nix usually will, if nothing's changed, it'll just be able to, yeah, there we go, instant. And we can actually run the thing that we built. OK, what's everyone's favorite verb? Sorry? Jump? OK, that works. So jump. Great, so that works. So that's how you use Nix to build something. Now I want to configure this as a service that I can run on a server somewhere. So this is the first bit of Nix code that I'll show you. These are the arguments that are going to be passed to this. So this essentially defines a function. And these are essentially, this is very much like dependency injection. So config is like the entire system configuration. Lib is the Nix library of helper functions. Packages is every single package that is known to Nix packages. Nix packages is a giant Git repository of every package that Nix knows how to build. It knows how to build other stuff too, but things kind of migrate towards that giant Git repository. It makes it really convenient. And Nix is a lazy, dynamically typed functional programming language, which is why it doesn't actually have to evaluate every single package. It only will evaluate what it cares about. And what I want to do is I want to define an attribute set. So an attribute set is Nix lingo for a dictionary or a hash map or something like that. And it has two keys. One is options, the options that I'm allowed to set on the service, and config, the generated configuration once I've set those options. So to do that, the first thing I want to do is I want to do the programmatic equivalent of the Nix build that I just did. And for Nix, that's called call package. So I'm going to go ahead and do that. You can kind of specify which set of packages you want if you want to override the default, but I've just gone ahead and done that for completeness. So again, options and config. I haven't told you what those are just yet. So the option that I want is I want to have an option to enable or disable the service. And again, the Nix library of helper functions gives me an option to just make an option that, if enabled, is yes, and true, and if it's false, is no. And if it's enabled, then I need to do something in my generated config. So I guess this is the most complicated part of the Nix code I'm going to show you. So what I want to do is Nix won't open a port in the firewall unless I tell it to. So I wanted to open a port 3000 because that's a port that I used in my example. It also generated a systemd service. So systemd is a service manager, does a whole lot of stuff. But this, if you have written systemd services or you're involved in that stuff, might look somewhat familiar. It's essentially a DSL. So these are all things that. So a bit later, I'll show you that this actually turns into a systemd unit file. But for now, just yeah, this looks very similar to systemd config. And is this functional? I would argue yes. It doesn't actually mutate any state in your current directory except for that symlink, which you can easily remove if you want. I'm declaring exactly what I want and just letting the one command nix build make everything happen. I think that's pretty good. So let's ship it. So I'm going to create another file called web server. And I'm going to enable my service because that's important. So I'm just going to go ahead and I'm going to go to a slightly different directory. So yep, it's there. I want to create. Oh yeah. So now that I've created that file, I can run this command to actually like take the config that I've done and output the every time. Sorry, I always like struggle with like copying this line. It's a bit of a pain. I'm just going to go ahead and do that. Oh no. Yep. Okay. Great. So I can it's bigger, and I can actually. So if you're familiar with systemd unit files, I wasn't until a couple of years ago. What it does is that so one of the ways that nix accomplishes what it accomplishes is that it sets the path. It controls what the path environment variable is set to, and it uses the inputs of whatever you're building to determine the hash of the outputs. So it's very much like Git in that sense. This extra bit here is for my benefit. So it specifies a path, and every like I said, inputs uniquely identify the outputs. So that works pretty well. And this is just otherwise this is a systemd service like any other service. So okay, so that's what we've done so far. And now I want to deploy it. So this file is called trivial.nix because I'm going to be using nixops, and nixops has a manual, and this is a trivial example in nixops. So I'm gonna. I don't think it's trivial, but I thought it would be good to like give you something that you can refer back to or link back to the official documentation. So that's what it looks like. Now I want to deploy to VirtualBox because I didn't think wrangling AWS would have been a good idea for a live demo. But anyway, so I want a VirtualBox VM. I want it to be headless, so I don't want a GUI to pop up. I want it to have a gig of RAM and 2 virtual CPUs, and I want it to be running. I expect it to be running Linux. So great. Then I can do a deployment. So I'm going to be using nixops. Nixops is a tool very much like Puppet or Chef or Ansible, but built on top of everything that Nix offers. So I can, just to show you that I've got nothing, in my sleeves. I don't have any deployments right now, so I'm going to create a deployment. -d is short for deployment, -- deployment. Oh, sorry. I will do that next. Okay, created a deployment. I'm going to deploy my deployment. So it's going to create a VirtualBox machine, attach a disk to that virtual machine, and copy everything that I care about. So that means my Haskell service and all its dependencies, and all its dependencies, so on and so forth, which is called the transitive closure to this VirtualBox virtual machine. So the command that actually does the magic of like copying everything over is called nix copy closure because it copies the transitive closure of stuff over. It's really useful. It's great. Another thing that Nix offers you is that it gives you binary caching. So if you've built something on a binary cache, which is a machine that's accessible to your current machine by Nix, then Nix will actually query that binary cache before trying to build something. And if it's already been built, it'll just copy it back down. So very straightforward. So it's copying everything over. It should be pretty fast because it's just on my local machine. And as you can see, the IP address, I'm not sure if you can, is 192.168.56 and 101. So I guess the next thing to do is to, after this completes successfully, is to ask what your other favorite verb is. Kill. Kill? OK. Don't know what you do in your free time, but hey, so that works. So is this functional? I would argue yes. I declared, at least it's declarative. I said exactly what I wanted. I wanted a VirtualBox virtual machine. I wanted this service on that machine. Make it happen, Nix, and it did. So excellent, right? We can all go home. DevOps is solved forever. Except that requirements change, right? This is the reality of our lives as software engineers. So what's wrong with the service that what's wrong with this code? Does anyone notice anything that jumps out at them as being extremely bad? No? OK. Sorry? No, I was going to say, I'm hard-coding the port here. Who does that? It's very bad. So what this means is, since I've hard-coded the port, I can't run 2 instances of the service on the same machine if I ever wanted to do that. And I can't run something else on port 3000 if I wanted to do that as well. So really, this is not good enough, right? What I want is I want to be able to specify the port that I want. And ideally, I'd be able to go back to the devs and be like, hey, you hard-coded the port. What are you doing? Fix it, please. And they would fix it. But in practice, often, developers are working on something else, and you want this right now, and they're too busy working. It happens. And lest you think this is a contrived example, this definitely happens with all kinds of upstream and downstream software, even outside of the world of DevOps. So it's really important to be able to control every aspect of the software engineering yourself. And Nix gives you that. It allows you to actually patch a package that you're building at any stage. So Nix builds things in stages called and there's a patch. Phases is what it calls them. So there's a patch phase. So what I'm going to do is I'm going to change the import to include this Haskell function called getArgs, which allows me to take command line parameters or arguments. And I'm going to change my previously hard-coded port to get the command line arguments and take the first one, and that's the new port. And you can just do essentially arbitrary bash commands in the patch phase. So I'm going to go ahead and cap the file that I'm patching just to show you that it is in fact doing the right thing. So if I do my Nix build of patched, OK, so you can see it did in fact do the patching that I wanted. Whoop, I'm going to scroll back up if I can. Yep. So you can see it got I patched it correctly. This should work. Indeed, it does. So then so now that I've patched it, I want to patch my service as well. So the only change that I need to make, I need to make more than one change here. I need to make sure that I'm importing my patched package. And I want to add an extra option so that I can choose the port that I want. That will default to 3000. So if I don't specify anything additionally, it'll just behave the way it did before. And I also need to go ahead and, when I'm running it, pass the port that I configured to it. So I've gone ahead and done that. And I want to import my patch service instead of my previous one, my unpatched service. So I'm going to go ahead and go to no. Weird. Where did it go? There we go. OK. Right. So I've changed that. And all I have to do is deploy again. Oh, whoop. Made a mistake. What port do people want? I'm just going to go to 3001. Is that OK with everyone? Great, it's done. What's everyone's other favorite verb? Bill? OK, great. hey, did it. So another thing is, for whatever reason I made a mistake, Nix ops allows me to actually list the generations. So I've made 2 deployments. I did the initial deployment, and I did the patch service as well. So if for whatever reason I wanted to roll back, I could totally do that. And as you can see, you didn't actually have to copy anything over because it still had the old deployment on the target. So if I go ahead and do that, and other favorite verb, deploy. Yay. So yeah. So in summary, Nix, it's a package manager. It's a programming language to configure packages in that package manager. It's also a build/environment tool. NixOS, I should have mentioned this earlier. NixOS is the operating system that's running on this laptop and also on any target that NixOps provisions. That's how NixOps works. It's an operating system built around Nix in the same way that you could think of Debian as being built around apt-get. You can't meaningfully separate apt-get from Debian and expect to get something that's meaningfully usable. NixOps is a tool that's very much like Chef, Puppet, Ansible, etc., built on top of NixOS. It handles provisioning and deployment. In practice, I would actually not recommend using NixOps just because you could just use Nix copy closure. It's not that much harder to use Nix copy closure yourself and do the provisioning with a more full-featured tool such as Terraform. But for a live demo, NixOps is perfect. And if you have a small deployment, it works just fine. So DevOps with Nix, is it automatic? Yeah, I ran 1 command, it worked. Repeatable, could I do the same thing on 100 machines? Yes, speaking from experience. Is it idempotent? Yes, as you can see, when nothing in my input changed, my outputs didn't change either. Is it reversible? Yes, I rolled back in front of you. Is it atomic? It does a lot of sibling swapping. So at the level of a level of a build, yes. At a level of a service, I think you would probably still want to have a bunch of machines behind a load balancer and do some load balancer angling in order to make sure that your user doesn't actually see anything weird. But but it does swap the symlinks over at the system level as well. Is it functional? Yes, I think so. I said what I wanted, just let the tool take care of the details, and it worked. And thank you. So we do surprisingly have time for questions. I have a bunch of suggested questions that you can ask, or you could just ask me something that's not on here. Please feel free. I will start here. Oh, OK. The question is, how can you? Oh, sorry. Yeah, I'm already wearing a mic. I forgot about that. The question is, how do you use this with SBT, the Scala build tool? So Nix works best when you kind of give it control over everything. But another thing you could do is you could just use it to provision the dependencies that you care about and drop yourself into a shell where you can just run SBT like you would otherwise. And this is something that I've done before. So that's one way you use it with SBT. There are other ways to use it as well, but I'm not familiar with those. Yes?
How would you deal with database migrations and rollbacks?
Question is, how do you deal with database migrations and rollbacks? That's a really good question. I don't really see anything in NixOps itself that is geared towards that. But I'd have to think about that some more. Other questions? Am I missing anyone? Yes? You.
NixOS for major upgrades, does it work just like installing other packages? Is it immutable?
Yes. Oh, yeah. So the whole rollback thing, the benefit. Why would you use NixOS over the reason you'd use NixOS over something like Debian? Sorry, did I repeat your question? Do NixOS upgrades and rollbacks work as easily as package upgrades and rollbacks do? The answer is yes. That's what I do. I run NixOS on all my laptops. Works great. It's very. So the nice thing about NixOS is that it'll kind of keep previous generations around until you garbage collect them. So if you decide that you want to upgrade, you can easily do that. And if you decide that your new upgrade is not really working out for you, you can very easily roll back. Works great. Yeah. Yes.
Why would you use this instead of Docker?
Good question. So as you can see, the DevOps story that I told you has no mentions of anything like Kubernetes or Docker or anything like that. And one reason for that is that in many cases, you don't actually need any of these tools to deploy your services to a machine. You can just go at the level of systemd, write a systemd service and expect it to work. Another answer to your question, but to actually answer your question, they're not necessarily in conflict. You can bake a Docker image using Nix tools and Nix packages. So you don't need Docker to make Docker images, and you can run a Docker image that contains software built by Nix. So they're not necessarily in conflict, but if you wanted to use one, if you wanted to use Nix by itself, you can do that. And one reason you want to use this over Docker without having Docker in your stack at all is that this is a lot faster than Docker is. So I mean, I have to do Docker stuff at work sometimes, but it's always very, very slow. It's an ordeal each time. Oh, I should mention where I work. So I work at this company in New York, Obsidian Systems. One reason I like working there is, can I go to the slide? Yes, is that we're all in Haskell and Nix. Previously, I worked at another company doing DevOps with Nix, which is where I learned most of the stuff that I'm telling you now. Yeah, but often we have clients who want us to do Docker things, and I guess we're like, fine, we'll do Docker things, but it's not fun. Any other questions? Right. Well, I guess since we have a couple more minutes, does anyone want to see me make a change in real time to my slides? So I use Docker to do my, sorry, I don't use Docker. I use Nix to do my, never. I use Nix to do a CI/CD thing for my slides, so I can make a change, and I use Travis to build and deploy my changes. So if I go to my presentation, oh. So I mentioned binary caching, right? So you can. So there are these two people who provide this service called CacheX. So I can actually go ahead and pre-populate my cache. So Travis doesn't actually have to do any building. So that's my personal CacheX cache. They'll give you one for free for 10 gigabytes for open source stuff, which my presentations are. OK, so then I can do a push. We can go to my GitHub and see this happening in, yeah, there we go. So it's my presentations repo. By the way, my presentation, this presentation is available at my, I don't know if you all can see that. Feel free to ask me for links, for the link to it later. I have a presentations repo. I've hooked up my domain name to GitHub Pages. So you should be able to see. So my build finished in 2 minutes. So I didn't actually have to. Oh, that's surprising. Oh well. Then I should be able to go to. I guess there's something in my cache that I didn't. Oh, that didn't work as well as I. What, sorry? Caching? Could be. I'm not sure. Oh, no, I didn't. Did I not push it? Maybe I didn't push it. Oh. Tried to live demo on Travis CI. Probably not a good idea anyway. But the point is that I have like my GitHub repo, and I have, Travis has some Nix integration. So the step that actually builds it, so I just have to specify the language is Nix, and I'm using my binary caches, and it all kind of hooks up and works, and yeah, cool. Yeah, I use the same system for my website, for my blog, for a bunch of other stuff. And if you're interested in talking about any of this stuff, please come find me afterwards. I guess we're at lunchtime, so thank you, everyone.